Okay. Okay, let's start. I think no one will join today. Okay. Okay. Last week we have discussed regarding Euler's theorem and Tonelli sum. So, have you gone through those topics? Any doubt? Have you gone through read those topics? How to resolve the um, quadratic equation? Have you gone through? Anyone?
Yes, sir, I read that.
Mm.
But
Oh,
uh,
yeah. Tell me.
Tony's stance was not so much clear.
Okay. Euler's is clear. Hello.
Yes, sir, that was clear.
Euler is clear. Okay.
Yes, sir, I
So,
read that.
what about
But
others?
uh,
Yeah. Tell me.
Tony's stance was not so much clear.
Okay. Euler's is clear. Euler's is clear. If I give you a problem for quadratic congruence, can you answer?
Yes, sir, that was clear.
Euler is clear. Okay.
Yes, sir, I
So,
read that.
what about
But
others?
uh,
Yeah. Tell me.
Tony's stance was not so much clear.
Okay. Euler's is clear. Euler's is clear.
Also, we can.
If I give you a problem for quadratic congruence, can you answer?
Yes, sir, that was clear.
Euler is clear. Okay.
Yes, sir, I
So,
read that.
what about
But
others? Yeah. Tell me.
Tony's
Okay.
stance was not so much clear.
Okay. Euler's is clear. Euler's is clear.
Also, we can.
If I give you a problem. Okay. Another thing, I asked everyone to install Linux. So that is done. And that is also pending. If you haven't installed Linux in your system, you cannot proceed with your project. Okay.
Yes, sir.
No one will join today. Okay. Okay. Last week we have discussed. Okay. Just assume one problem like x. Suppose x square congruent 5 modulo 41. Just tell me how to resolve. Can I resolve it using Euler or I need a Tonelli sign? Until unless the theory part is clear, we cannot proceed actually for the practical part. So for this, then I'm
So
helping.
we have to use transition
Okay. Okay. So what is the reason?
because the prime number is 41, which is 1 mod 4, and Euler's pattern is used for 16 mod 4 type prime numbers.
Sorry. Come again. What is the reason?
So because the prime number is 1 mod 4 type, and the Euler's formula is used
One
for the
mod
prime number.
four.
Sorry, sir, 1 modulo 4
What does it mean?
means when we divide the prime number by 4, we get one as remainder.
Okay. Okay. Correct. Mm-hmm.
But the Euler's formula is used for
Mm-hmm. Correct. Correct.
3 as remainder.
Okay. So now, suppose if I give you some another prime number like 17. 17 again. Okay, let's see if I have anything handy. Okay, 23. Okay, suppose if I give the same problem, okay, x square is equals to 5 mod 23. Uh, how what will be the answer? Can you quickly check? So what will be the first step? Can I directly put the Euler's formula, or I have to check something else? X square
Firstly, we have to
form.
check
Mm-hmm.
whether it is quadratic residue or not.
Correct, correct. So how to check the quadratic residue or not?
We will check 5 to the power
Hmm.
23 minus 1 by 2 is either 1 or
Correct.
mod 23 is either 1 or minus 1.
1 or minus 1. If it is 1, then
It is quadratic residue.
correct,
Then we will proceed with the next
correct.
formula.
Okay. After that, what will be the solution?
The solution will be 5 to the power
Mm-hmm.
24 by 4, which is 5 to the power 6 mod 23.
Hmm. Correct. Okay. Okay. So at least that part is clear. Now, mm, okay. Till now it is clear. So how if I have a quadratic equation, how to resolve? Okay. Now, the same thing we have to work out. Suppose I have a curve. Okay, curve is short versus curve. So equation of short versus curve is, any idea? Anyone? What is the equation of short versus curve? Y square is equals to x cube plus ax plus b. Okay. Now if I give you a curve, y square is equals to x cube plus ax plus b. Hmm. I will give you a b value as well as a prime number. Now first go for prime number 4k plus 3 format. Okay. Now if I have the curve y square is equals to x cube plus ax plus b, what we have to do? We have to put value x is equals to 0 to the prime number. Sorry, prime number minus 1. And I have to find out all values of y from the equation, Euler's equation. Okay. Can you do this thing till now?
Yes, sir.
Okay. So I have, if it is an infinite field, means it is a real life curve, I will go for minus infinity to plus infinity for the value of x. But if I am putting the value in a finite field, what I will get very limited value. Okay, like for 23, definitely I will get value less than uh, definitely less than 23. There is another theory called Hess's theorem. So according to Hess's theorem, I can find out. So that thing I will come later. Okay, according to Hess's theorem, I will get the value, the range of the finite number of points from the system. So that thing I will discuss later. Now I will just assuming that I will get point finite point less than the prime number. Okay, assume that thing now. Okay. Now, so I have a curve. I have x value. I have to find y value. Hmm. So till now, this thing is our task. Next is when I will get x value and y value. For getting y value, definitely I have to put, I have to go for Euler's theorem, and I have to find the y value. So I have got x value, y value. I have to put those values in a graph paper, or I have to plot in a graph paper. Then I will get all the points, finite points of those of that particular Shorter-Stress curve. Okay, so that is part one. Now, if I get the point, finite point of the curve, next I can do the remaining arithmetic operation, that is addition, subtraction, multiplication, and doubling. Okay. So that thing last week we have discussed that arithmetic operation you have already done on last semester. So formula is clear to you. You have to put the value on the formula. You will get the result. Okay. Now, which is not we have done earlier, that is division. So for division, we have to go for baby step, giant step algorithm. Okay. So how we will do the baby step, giant step algorithm? So for this reason, again we have some research paper. We have to go through some research paper where it is clearly mentioned how to implement the baby step, giant step algorithm. So uh, that is project of one group. I think group which group I have assigned baby step, giant step. Group 3. Group 3 will do the baby step, giant step. Okay. But before baby step, giant step, definitely we have to implement that point finding and all those things. Okay. Next is generator point. Okay. Generator point will come later. Now, as we have discussed, so for finding the finite point, we need to resolve the quadratic equation. Okay. Now, so Euler's is for prime number 4k plus 3. Now I will go to Tonelli-Sens algorithm. Okay, let me share my screen first. Please let me know if it is visible. Is it visible, my screen?
Yes, sir.
Okay. Okay. Now directly I will come to the algorithm part. Okay. So already you know it is a p should be a prime number is 4k plus 1 format. Now for algorithm, the step 1, I have to find a q and s value. Okay, I have p value. P minus 1 should be q into 2 to the power s. Okay, now come to the need to click this example. Okay. So here I can see they have represent 41 in 5 into p minus 1 is equals to 40. Now we have to represent 40 as q into 2 to the power s format, where q is equals to odd number. Q should be an odd number. So 5 into 2 to the power 3. If I put q is equals to 5 and s is equals to 3, I will it will fulfill my requirement. Now how I will achieve this value? Okay, so first I will go for put value of s is equals to 0. Okay, now what will happen? Q into 2 to the power s is equals to 40. Q into 2 to the power s is equals to 0. So q is equals to 40. Definitely q should be odd, so it will not satisfy my condition. I will change s value 0 to 1. Then q into 2 is equals to 40. So q will be 20. Again, q is a even number. So again, it is not satisfying my equation. Next, go for q is s is equals to 2. So 2 to the power 2, 2 square is equals to 4. Q into 4q is equals to 40. Then again q is equals to 10. It is not satisfying. Now s is equals to 3. So 2 cube means 8. Q into 8 is equals to 40. Now q into 8 is equals to 40 means q is equals to 5. Now I got q is equals to q is an odd number. So my condition satisfied. I will get s is equals to 3, q is equals to 5. I will get the first condition. Okay. This is the step 1. Next step is I have to search for a number z where it should be a quadratic, not a residue. Again, from Euler's theorem, what I can know, z to the power prime number minus 1 by 2 mod p is equals to 1. So again, it is a quadratic residue. It will not satisfy. Z is equals to 2. It is not working. Z is equals to 3. Again, z to the power n minus 1 by 2. Sorry, p minus 1 by 2 is equals to 40. 40 mod 41 is equals to minus 1. So it is a quadratic non-residue. I am getting z value is equals to 3. Up to step number 2. Is it clear for all? If you have any doubt, please let me know.
Sir, can you repeat one more time?
Yeah, definitely. So, what is Euler's criterion saying? What is the formula for quadratic residue or non-residue? How can I get? Suppose, how can I say? 14. 14, you can go for, do you have the book, Farhausen? Anyone has the book Farhausen? No, I think. Okay, no problem. Okay, suppose I have a number 14, okay, and prime number is equals to 23. Now tell me, how can I get 14 is a quadratic residue or not. How can I get? So what I can do, 14 to the power 23 minus 1 by 2 mod 23. If it is minus 1, it is a quadratic non-residue. If it is a plus 1, it is a quadratic residue. Okay, this part is clear. The Euler's theorem for finding quadratic residue or non-residue. I have to put the formula number to the power prime number minus 1 by 2 mod the prime number. If I get minus 1, it is a non-residue. If I get plus 1, it is a residue, quadratic residue. The Euler's theorem is clear for all. I will put the same value here. P, the value of P, I'm sorry, value of Z. I will put first Z is equals to 2. 2 to the power 41 minus 1 by 2 mod 41. It will give 1. Next, 3 to the Z is equals to 3. 3 to the power 41 minus 1 by 2 is equals to 40. That means again mod 41. I will get minus 1. If I get minus 1, that means it is a quadratic non-residue. Okay. Is it okay now?
Yes, sir. Yes, sir.
Okay. So up to step 2, it is clear. Now I will go for step 3. What step 3 is saying? I have to initiate one value, one variable m, c, t, and r. I will value of m should be first value of initial value of m should be s. I have got s from here. I have got z. Z to the power q should be value of c. T will be n to the power q. Okay. And r will be n to the power q plus 1 by 2. Again, let's see. So initially I have got q is equals to 5, s is equals to 3, z is equals to 3. Okay. Hence, m is equals to 3, c is equals to z to the power q, that means 3 to the power 5, that is 38. 3 to the power 5 mod 40 actually. Okay. Next, t is equals to n to the power q. N to the power n means 5. Q is equals to 5. So again mod 40 is equals to 9. R is equals to n to the power q plus 1 by 2 mod 40, that is 2. So I have got MCTR value. Okay. That is the initial value of that 4 variable. Now I have to run a loop. What will be the condition? If t is equals to 0, return r is equals to 0. If t is equals to 1, return r is equals to capital R. Okay, r means result. Now, first iteration of the loop. T, I have got 9. So t not equals to 1. If t is equals to 0 or 1, then I have to do the condition, else t not equals to 1, so it is not finished. Now again, t to the power 2 by 1. Okay, mod 40 is equals to 1. I is equals to the value of I is equals to 2 iteration. Next, okay, that is the else condition. Sorry, I missed the else condition. Else condition is I within 0 to m such that t to the power 2 to the power 1 is equals to 1. Let's see. t to the power 2 to the power 1 mod 40 is equals to 1. So I is equals to 2. Let b value should be c to the power 2 to the power m minus I minus 1. Let's see what is the b value. C to the power 2 to the power m minus I minus 1. C to the power 2, c is equals to 38 is equals to 2 to the power m I and 1. I is equals to 2, m is equals to 3, and 1 means 1. So that is 38. Okay. So you can go for any online modulo calculator. Modular arithmetic. Okay. Here, if I go for this calculator, I can do the same kind of operation 2 to the power whatever modulo. I will get the same result. Okay. So for your calculation, you can use this kind of online tool, which will help you to find out the exact value. Okay. Okay. Next, come to the next part. So B, I have got value till B. Okay. Now M. M should be I, C should be B square, T should be TB square, R should be RB. I will go till I have got these two conditions. If the else condition, I have to go for another loop. Okay. I know it will be little bit difficult to understand, but when you will do the sum in your paper pen, you will gradually understand. Okay. So I have got the value of all those variables. Now I will go for the second iteration. So again, I have got t is equals to 40, so not equals to 1. So again, I have to do the repeat the same steps. Okay. And at the end of second iteration, I have got t is equals to 1. Okay. So in third iteration, I will stop, because if t is equals to 1, return r is equals to r. That means r is equals to 28. So hence minus on plus 28 square is equals to our value, that is 5. Okay. So I will request all of you kindly do the math in your exercise book. Then it will be easy to understand. Okay. Now tell me if any steps is not clear to you. Okay, it seems all are clear. Okay. So that's how, using Tornelli-Sank, we have got the solution of the quadratic equation, where the prime number is 4k plus 1 format. Okay. Now, what you can do, you can go through the same example and try to write your own algorithm. Okay, or whatever language you are comfortable, C, Java, C++, Python, whatever. Try to implement the thing. Okay, don't go for the large number. Go for the simple, very small number, like the same thing. 5 is equals to x square modulo, that is for 41. You can go for another number like 40, 50, 51, no, 51, 17 you can go for. Okay, and you just check it is working properly or not. Okay, then it will be clear. So for today, I'm not go more. Just go through the correlation algorithm, the example, and try to implement. Okay, and it will be better if you implement this algorithm in the code in Python. It will work two things. Your Python language will be also clear, Python language concept, as well as the correlation algo also will be clear for you. Okay. Next week, I will give you the uh, C code for correlation. Okay. Before that, I will ask each of you to go through, or you can do in group, no problem. Write the code in Python, it will be better, or else C, or whatever you are comfortable. Just check your understanding is clear or not. Okay. Okay. So we today we have learned uh, how to resolve the quadratic equation. It is in two form: prime number 4k plus 1, 4k plus 3. So both thing we can resolve. Next, what we have to do, again from the uh, equation equation of short Westes curve, I have to go for I have to find out the finite points of the equation. Now, when I have got the finite points, I have to plot it in a graph paper. Lots of online graph paper is there. You can use that thing, or you can use the real graph paper. You can download from net and you can print out, and there also you can plot. Just check the graph is symmetrical or not. Okay, if I take a curve, elliptic curve, short distance elliptic curve, it will be a symmetrical along with our y-axis. So same thing will be happen in our finite field also. Okay, so that's how I can check whatever my result I have got, it is correct or not. Okay, so lots of things today I have discussed. First is how to resolve the equation. Next is how I will get the finite point from the infinite curve. And next, how to check it is working properly or not. Okay. So that three thing is required first. So go through this thing. Let's see if any documents has this. Okay, let me share one more thing. Is it visible to all?
Yes, sir.
Okay. So it is a curve y square is equals to x cube plus ax plus b. So we are changing the a and b value. So according to the a and b value, we are getting different types of curve. Okay, so every time we can see it is a mirror image. If I think x-axis as a mirror, it will mirror image of another part. Okay, so if I go for imagine x-axis is a mirror, and I will get the plus part of the y in the minus negative part of the y-axis. Okay, so it will be applicable for all three. Hmm. Now in slide number 10, it is mentioned how I have got the value, finite value of the curve. Okay, so same thing, same curve, x cube plus x mod m, y square is what is the curve equation? Okay, m is equals to sorry, y square is equals to x cube plus x mod m. So I have put the value of x from 1 to 22, and I will get the y value. Okay, so if it is x is equals to 1, y is equals to 5 and 18, x is equals to 9, y is equals to 5 and 18, x is equals to 11, y is equals to 10 and 13, x is equals to 13, then y is equals to 5 and 18. That's how we are getting the points. Okay, now I have put all points in graph paper, and again I can see it is a symmetric graph. Okay, if I imagine line number that point 11 to 12 as a mirror, I put mirror between 11 and 12 of x sorry y value along with x axis, I will get two mirror image. Okay, same for other curves also. That is for y square is equals to s cube plus 10x plus 2, where f prime number is equals to 23, and y square is equals to x cube plus 22x plus 18, again prime number is equals to 23. So everyone has these documents. So you can put x value, y value, uh, resolve the equation, and you will get the same curve. Okay, so you can do this thing in pen and paper, and you will check whatever you have done, it is working properly or not. Okay, after that that formula of addition subtraction is there. So again formula is mentioned here, how to do addition. Okay, that is the, if I want to add 2 point p and q, then result will be r. Then what x coordinate of r point will be l square minus xp minus xq, where L is equals to what is the L's formula? L is equals to 3xp square plus a by 2y yp. Okay, so that's how I have got x value, y value. Same thing for subtraction. Doubling is we add the same value twice. Let's see, doubling is mentioned. That is also addition. Doubling of 2 point. Okay, and finally multiplication. Subtraction is also there. Example of multiplication. Multiplication means if I want to add 4, it is a scalar multiplication, not for subtraction addition. I am adding 2 point or subtracting 2 point. But for multiplication, I am multiply with a scalar number. Okay, like 4, 5, 6. So that is scalar multiplication. So 2 means adding twice, 3 means adding thrice, 4 means adding same thing 4 times. So 9 comma 5 plus 9 comma 5 plus 9 comma 5 plus 9 comma 5. In this way, repetitive addition giving the result of multiplication. Okay. So up to that, you just do this thing paper and pen and try to write the code in Python. It will be the best approach. Then your logic will clear. Don't go for the addition subtraction. That thing you can do in pen paper. Don't go for the addition subtraction. First, you find the point using Tonelli-Senk and Euler's. Okay, do that thing. Maybe next week. Is it okay if we meet next week, or you need one more week time, 2 weeks time? Will we meet on 10th or 17th? But I need the full thing. Today I have discussed Euler's already cleared for you. Tonelli-Senk and how to get the point. I need implementation in code for getting all those points for a finite field, for a curve. Okay. So when I can get 10th is okay, or you need till 17th?
So we have to code for Tonelli-Senk algorithm.
Correct. Not only Tonelli-Senk. See, I will give you a curve. You will show me the code on next day. I will give you the equation is constant. I will give the value of A, B, P, and I will check it is giving the correct finite points or not. I will give P 4K plus 3 format or 4K plus 1 format. If I will give in 4K plus 3 format, it will execute the Euler's formula and it will give the final result. I will give the 4K plus 1, it will go for the Tonelli-Senk and it will give the result. So all those things will be satisfied. So I need the full code. I am not asking you to plot. Plot is different thing. Later on you can do the plotting. First I need to find out the points. Okay. Plotting later on I will do, because for plotting we need extra library or whatsoever. But at least I can do the arithmetic and I can find out the finite points. Okay.
Sir, so do we have to write the code for finding the finite points on a curve?
Means the X and Y value.
Okay, sir. So, sir, 17 August will be better, I guess.
Okay. Okay, no problem. Then I will we will meet again on 17th of August. Okay.
Okay, sir.
So is it clear for all? Correct. What is our next step? How should we proceed?
So we have to find the value of x and y for the
Hmm.
points.
See, I will give you the equation of the curve again. I let me share my screen again. See, this is my. I will give the curve. Suppose this one. Y square is equals to x cube plus ax plus b. So I will give you the value a is equals to 10, b is equals to 2, p prime number is equals to 23. Okay. If I give you that thing, it will give 24 points. Clear? It will give 24 finite points. 1, 2, 3, 4, 5. In this way, I will get 24 finite points. Okay. Same thing. If I give here 41 instead of 23, same thing. It will maybe 26, 27, whatever point it will give, but it will execute the Tonelli-Shanks algorithm. Okay. But it will give the same number. So not same. Whatever point is will be the outcome. It will give. Okay. I have the tool, online tool. I will verify this thing, whatever you have code written, it is working properly or not. Okay. So I will ask everyone after writing code, please test thoroughly. It should not give any uh, unhandled exception. If I give something, some suppose a is equals to m, like I will give any character, it should not break. Code should not break. It will, the all exceptions should be handled properly. Okay. If I give some value, suppose f is equals to 10, sorry, prime number is equals to 10, it will give error message that 10 is not a prime number, please provide proper prime number. Okay. Or do one thing, if I have give 10, it will take the next prime number. So after 10, prime number is equals to 11. Correct. So it will give you the message 10 is not a prime number, so I will take the next prime number 11. If I give prime number is equals to 40, it will say that 40 is not a prime number. I will go for 41, which is the prime number. Okay, because for a large number, suppose it is a three digit number. For now, later on we will go for 100-digit number. For now, suppose I will give you a 3-digit prime number. It will be difficult to find out. Okay, 439 is a prime number or not. So I have to do so better. Whatever number I will give, it will take. If it is a prime number, okay. Else it will take the next prime number. Okay. In this way, it will execute. Okay. So for now, all three group work together. Okay, and you can do in this way. One group can do Tonelli-Shank, one group can do Euler. That thing also possible. So that is up to you how you will work. But for now, you please go through, implement this thing on Python. It will be better. Later on, I will give you the C code. If you have any problem in understanding, I will give you the C code. Okay, but I want something, some effort from your side. Okay. Okay, I think nothing for tomorrow today. Okay, then we will meet on next 17th of August. Okay.
Yes, sir.
Okay. Thanks all.
Okay. Thank you, sir.
Bye. Bye. Good night.
Bye, sir.